this, so that the points A 1 to 7, B 2 6 3 and C are collinear points. Collinear means suppose in the space points like this, somewhere A, somewhere B, and somewhere C. So these points are collinear. It means if I try to find if I try to get this AB vector length, okay, AB vector. How to get AB vector? OB minus OA. Then I will find BC length. How to get BC vector? OC minus OB. Then I will get AC. Okay, AC, OC minus OA. I have all the three lengths. So if they are collinear, it means the complete length equals to the sum of remaining two. Given points. Solid and that's it. Given points. What is that? Huh? Laser. Who's doing this? All these things? Huh? Simply wasting our time, not mine. Given points. A point is A 1, 2, 7. And what is B point? 2, 6, 3. C point 3, 10, minus 1. Okay, 3, 10, minus 1. So we want to prove these are two linear points. So what I will do? Firstly, I will find AB vector and DC vector and AC vector. So firstly, write AB vector. AB vector. AB vector. AB vector. AB vector is OB minus OA. AB vector is OB minus OA. OB vector minus OA vector. Can you tell me directly what is the answer? 2 minus 1. 2 minus 1 I cap. Let's write like this. 2 minus 1 I cap plus 6 minus 2 J cap plus 3 minus 7 K cap. Then what is the answer? AB vector. AB vector is I cap plus 4 J and minus 4 K cap. Okay. Next, we need BC vector. What is BC vector? BC is OC minus OA. OC minus OA. So C, this OC minus OB. Correct. OC minus OB. OC minus 3 minus 2. Can I write now direct? 3 minus 2 I cap and 10 minus 6 4 J cap and minus 2 minus 3 minus 4 K cap. After that, AB BC, then AC vector. OC minus OA. So 3 minus 1 2 I cap 10 minus 2 8 J cap minus 1 minus 7 8 K cap. Then I need length AB, length BC, length AC. Then what is AB length? Length means mod of AB. It is root over 1 square is 1, 4 square 60, and again minus 4 whole square again 60. So it is 16, 16, 32 and 33. What is BC length? Mod BC. It is BC is 1 square is 1 and here 4. 4 square is 60 and here minus 4 whole square is again 60. So answer is again 33. Okay. What is AC length? AC root over 2 square 4 plus 8 square 64 plus minus 8 square again 64. 64 plus 1 132. So is it following AC vector equals to AB plus BC vector? Is it following? Tell me, is it following? What is 132? 2 6 are 12, 2 6 are 12. Then 233. It means this vector can be written as like this: 2 root 33. Correct now? 2 into 2 4. 4 into 33, 130. So very clear here. Clearly, AC vector equals to AB vector plus BC vector. It implies A, B, C are collinear points. Okay, A, B, C are collinear points. Okay, next. 17 is show that the vectors, this vector 2i minus j plus k, I minus 3j minus 5k, 3i minus 4j minus 5k form the vertices of a right angle triangle. These are the vertices of a right angle triangle. It means if I try to find length AB vector, length BC and length AC, then they will follow the height of one square. Biggest side whole square equals to sum of the square of the other two. 17. ABC vector. Let first vector is A vector. Okay. Second vector is B vector. And third vector is C vector. One by one tell. First vector is 2i minus j plus k. Second vector I minus 3j minus 5. Third minus 4j cap minus 4k cap. Okay, these are ABC vectors. Okay, these three vectors forms the vertices of a right angle triangle. Okay, ABC. So suppose triangle like this. If you want to see triangle like this, suppose ABC. This here A point, here B point, here C point. So A vector, this is B vector, and this is C vector. So if I want to find AB vector, it means B vector minus A vector. No? If I want to find AC vector, then C vector minus A vector. And again BC vector, C vector minus B vector. Correct now? Because it is length AB vector. Length AB vector means this position vector of B point minus position vector of A point. So here if I say, okay, if I say here vector A, vector B, and vector C, okay, are the projection vectors of points A, B, C. Okay, A, B, C. Then what is AB vector? A vector is B vector minus A vector. If B is the position vector of this segment, it is OB minus OB. Same it is. Same the question same. But little language change. B vector minus A vector. So B vector minus A vector is this minus this. And it means 1 minus 2. 1 minus 2. That is minus I cap. And minus 3 and minus 1. Minus 3 minus plus 1. So minus 3 is minus 2j. Minus 2j and minus 5 minus 1 minus 6k. And BC vector is C vector minus B vector. C vector minus B vector. So 3 minus 1, 2i. Okay. And minus 4 minus 3 plus 3 minus 4 plus 3 is plus 1. C cap minus 4 minus plus it is k cap. Yes, you are correct. Because minus 4 plus 3. AC vector, AB, BC, AC vector. AC vector is C vector minus A vector. C vector minus 3 minus 2, I. Okay, minus 4 and minus plus. Minus 3z. Minus 4, minus 1, minus 5. Okay, then again length AB, length BC, length BC. Length AB, length AB, length AB, length BC, length BC. Then AB length. But at a time if I try to find AB square, then square root will not be there because AB means moved over. So mod AB square means only minus 1 whole square. Only minus 1 whole square plus minus 2 whole square plus minus 6 whole square. So it is 1 square 1 plus 4 plus 36. It is 36, 41. Then what is BC length? BC length, but I will calculate a square because we are proving that these are the vertices of a right angle triangle. So we need to calculate that squares also because we will be satisfying Pythagoras in that square is there. So BC this whole square 2 square plus minus 1 whole square plus 1 square. So 2 square 4 and 1 5 and 6. BC vector whole square 1 square plus minus 3 whole square plus minus 5 whole square. So what is this? 1, 9, 10 and 25. How much? 30. 35 plus 6. 41 equals to 41. That is fine. Clearly here, mod AC whole square equals to mod AB square plus mod BC square. It implies given vectors. It implies given vectors A, B, C are the vertices of a right angle triangle. Suppose this question is prove that these are the vertices of an equilateral triangle. It means mod AB, mod BC, mod AC all will be same. An equilateral triangle. Correct? 18. 18 you try to solve this first. Take a minute and try to solve. Okay. Just highlight the keywords whenever you get anything important. See, vector A is non-zero vector. Non-zero vector means mod A is non-zero. And also mod A is small a. Vector A is non-zero vector of magnitude A. Magnitude A means mod A. This is magnitude is small a given. And lambda is a non-zero scalar. Lambda is a non-zero scalar, so lambda may be negative also, possible, maybe positive also, but not zero. So that lambda A becomes a unit vector. If lambda A becomes unit vector, lambda A vector is a unit vector. It means if I calculate magnitude of lambda A vector, it should be 1. It must be 1. It means from here I can write lambda A vector equals to unit vector. It means its mod equals to 1. Whenever unit vector, magnitude is 1. Okay. And whenever any scalar out from the mod, any scalar out from the mod, it means positive length is positive. So if I take lambda out, it will come like this, mod lambda out. If I try to keep lambda out, it will come mod lambda. Because lambda is non-zero. If it is negative, suppose I took minus 2 common, then outside it will be plus 2 because it is the length. And mod A equals to 1. But mod A is small a. That means mod lambda A equals to 1. Then what is the A value? A value 1 upon mod lambda. From here, what is A value? 1 upon mod. This option is correct. So they can take one more option. Mod lambda equals to 1 upon A. If this is possible, then also unit vector. Okay, but according to option D only correct. Okay, note this.